just define a term. It is called critical number. Okay, so what do we mean by critical number? Is let f is defined at x equals to c. Suppose a function is defined at a point x equals to c. Okay, if the first derivative of the if the derivative of the function at c is 0, what do you mean by that? When the derivative is 0, the derivative is 0 if the tangent is parallel to x-axis, right? If the slope is 0. Slope is 0 means, for example, in this case, the tangent is parallel to x-axis, right? In this case, the tangent is parallel to x-axis. So if f prime of c, if the derivative is 0 or fx is not differentiable at x equals to c. Look at this. Fx is not differentiable at x equals to 3. Why? Because there is a sharp corner. The function is continuous at x equals to 3 because there is no break, but it is not differentiable. If a function has sharp corner at a point, then it is not differentiable at that point. Okay, see this example where a graph is given. Okay, the function is defined from -1 through 7. It is defined everywhere, right? But the function is not continuous. You see that at 6 there is a hole in it, but the function is defined differently. It is removable discontinuity, right? Because the left limit and the right limit exist, but the function value is different, so we can remove it and make it continuous. But the question is not whether it is a removable discontinuity or not. We want to find out the critical points, local max, local mean, and so on here. Okay, so let us start. What are the critical numbers? Critical numbers are the one where either the slope is 0 or the function doesn't have derivative or the derivative does not exist, right? What are the points where the slope are 0? So -2 and +1, that are the slope 0. So x equals -2, x equals to, let me use different color, x equals to -2 and +1. Also, the function, the derivative does not exist at 3 because there is a sharp corner, right? And then so it is 3. And then at 6, the derivative does not exist. Why? Because the function is not continuous. If a function is not continuous, then the derivative does not exist at that point, right? So 6 as well. Okay, what is the local max and local mean? So let's find out the max. Local max at x equals to max is, this is the local max because at around 1, this at 1 is the highest point. The height of the function is the maximum at 1 when you compare to the points around 1. So this is 1, and at 6 as well, right? At 6 it has local max because at 6 the height is like a 5, right? 5 here, the height is 5, and around 6 the height is basically smaller than 6, right? Smaller than 5. So what you do is you will write x equals to 1 and 6, and local mean will be x equals to -2 because at -2 it is the lowest height, and at 3 it is the lowest height, right? Okay, and how about the global max and global mean? Global max is the one that has the highest of those, so it is at x equals to 6, the global max, that is the max, right? And it looks like this is the smallest one, right? At x equals to 3, x equals to 3 is the global mean. Okay, so from here you can see that a function can have local max or local mean or global max or global mean even though the function is not continuous at that point. But the function must be defined though. Okay, the function must be defined. For example, if that point was not there, then you cannot say that what is the value of function at 6. You cannot say whether that is bigger than the surrounding points or height at the surrounding points or smaller. Since it is defined everywhere, then we can have local max or local mean there. Okay guys, so at 6 there is a global max and global mean. At 3 it has a global at 6 there is a global max and local max. At 3 there is a global mean and local mean as well. So let us summarize this. So if fx has local max or local mean at x equals to c, then c must be a critical point, okay? Because the local max or local mean can exist at a point where the derivative is 0 or the derivative is not defined, okay? So meaning that if there is a local max or local mean at x equals to c, then c is a critical point or a critical number. In other words, local max or local mean always occur at critical numbers. Okay, but if there is a critical number, there may or may not be local max or local mean. The converse may is not always true. But if there is a local max and local mean, it must be always at the critical point of a function. Okay, so how do I find out absolute or global max or global mean in an not open, closed interval? Okay, in a closed interval. So if you are trying to find out a global max or global mean in a closed interval, how do I find out that? These are the steps. Number one, find the critical numbers. How do I find the critical numbers? Find f prime of x and then see where f prime of x is 0 or undefined. What we do is you find out f prime of x and set that equals to 0, and then you will see where it is 0 or undefined. And those are the critical numbers. Find fx at each critical numbers and at the endpoints. Okay, so you plug in those critical number on fx in the question, and then also plug in the endpoints on the question, and then you will see which one is the mix. The minimum one, the smallest one is the minimum, and the biggest one is the maximum. And again, the function must be defined in the interval for local max or local mean. Okay, otherwise you cannot say for sure. Okay, let us look at this example. Find the critical numbers for fx equals to 2x cubed minus 6x on the interval 0 to 3. You want to find out the critical numbers for this. Okay, so how do I find out that? Let's do. Solution is to find out the critical numbers, you find out f prime of x first. What is f prime of x? It is 2 times 3x squared minus 6 times 1. The derivative of x cubed is 3x squared minus derivative of 6x is 1. So 6 times 1. So that is by basically how do you get 6x squared minus 6, right? For critical values, for critical numbers, what you do f prime of x must be either 0 or undefined. Okay, since there is no x value that is not defined, so what we do is you just say that equals to, if there is x in the denominator, then you would say what values of x will give this function undefined, right? But there is no x in the denominator, so we don't have to worry about that. So you do 6x squared minus 6 equals to 0. Add 6 on both sides. Okay, 6x squared equals to 6, right? Because you cancel that. So divide by 6. By 6 you get x squared equals to 1. So what is the x value? X will be plus minus 1. But the interval given here is between 0 to 3 only. So what is the answer then? So answer must be x equals to 1 only, because x equals to negative 1 is outside this interval, outside the given interval. Okay, that's why we pick just 1. Otherwise it would be plus minus 1. Okay, next example. Find the critical numbers of fx equals to x and the root under 4 minus x. That's what you want to do. So how do I find out that is, so so to do that you find out f prime of x. So how do I find out the f prime of x? It is just the product rule, right? F times g. So it is like, you can write derivative of f. What is the formula? F prime times g plus f times g prime, right? So f prime is 1 times g is root under 4 minus x. You see that? And then plus, right? Plus, what do you get? Plus f times g prime. What is the derivative of root under 4 minus x? How do you find out that derivative? It is similar to 4 minus x to the 1/2, right? It is like u to the 1/2. You can think this as u, basically. You can think this as u. So u to the 1/2. So what is the formula for that? U to the 1/2. It is n u is 4 minus x times to the 1 n minus 1, 1/2 minus 1 times the derivative of u, right? Negative 1, because the derivative of 4 minus x is 0 minus 1. Okay, so if you simplify this, what do you get? Root under 4 minus x times 1 is root under 4 minus x, plus you see that x over 2 times, what do you write this one? You can add 1 over root 4 minus x, right? And then there is negative 1 there, negative 1 times that. Why did I do that? Because the exponent will be negative 1/2. If you move to the denominator, it will be positive 1/2, but that is basically root, right? Now I want to combine these two. What do I get? Do you know how to combine that? You can write this as basically there is 1 in the denominator and then you multiply those two, right? So what you get is basically 2 root under 4 minus x, right? And then do the cross multiplication, right? How do I do that? So it will look like this times that and then this times that, right? So what you get is root under 4 minus x times 2 root under 4 minus x will be 2 and then 4 minus x. You see that? That's what you get. And then plus 1 times x times negative 1 will be negative x. That's what you get. So if you simplify that, what do you get? 8 minus 2x, right? And then minus x. 2x minus x over 2 under root 4 minus x. So we're going to find out the critical numbers. For the critical numbers, this should be either 0 or undefined, right? For what values of x it is undefined? If you set x equals to 4, it will be 0 in the denominator and that will be undefined, right? So x equals to 4 is 1, but you want to take only for x less than 3. So you don't have to worry about x equals to 4. So what you get is basically, let me simplify this one more time. So 8 minus 3x over 2 root under 4 minus x. That's what you get, right? Now, so when does f prime equals to 0? If f prime is 0, the numerator must be equals to 0, right? That is 8 minus 3x equals to 0. If you solve, if you subtract 8 and divide by 3, negative 3, you will get x equals to 8/3. So 8/3 is 2 point something, which falls less than 3, right? Which is less than 3. So this is the only critical number. Why is that? Because there were 2 basically, but this critical number does not fall in that region. It is not less than 3. It is x equals to 4 will give you 0 in the denominator and non-zero in the numerator. That will give you f prime not defined at x equals to 4 and f prime is 0 at 8/3, x equals to 8/3. Since x equals to 4 is not in that region, so x equals to 8/3 is basically the this is the critical number.